So good morning students, welcome back. Today in this chapter AC, alternating current, we are going to discuss one of the most important topic, phase angle. We'll find the phase angle between current and voltage. Okay. So before finding phase angle between current and voltage, I want to introduce you what is the meaning of phase angle. Phase angle is a physical quantity that explains the position. Okay. It is represented by omega t, sometimes it is represented by phi. Suppose an object is moving from A to B along the circular path. So in moving A to B, the angle traveled by the object, this angular displacement is said to be phase angle. Okay, that shows the position of an object. So now look at students, what we'll find? We'll find the phase angle between current and voltage. Okay, find phase angle between current and voltage. We are having the first case when resistance R is connected with an AC source. We are having only one component, resistance. So look at students, we are having a resistance R that is connected with AC source. This, as you know, this is symbol of alternating source. So we know what is the phase angle of, what is the EMF of an AC source? E equals to E naught sin omega t, where E is the voltage, alternating voltage, and E naught is said to be peak or maximum voltage. Okay, and this angle is said to be phase angle. Okay, omega t. Omega is angular frequency. Now students, this is resistance, so we can apply Ohm's law. What is Ohm's law? E equals to IR. I am using EMF here. Okay, now compare both from first and second. When left hand side equal, right hand side will also equal. So this IR will equals to E naught sin omega t. Simple. Now transfer the R, okay, downward side. E naught is the peak EMF and R is resistance. Peak EMF by resistance, it is said to be peak current, maximum current of alternating source. So we get I equals to I naught sin omega t. Look at students, what was the phase angle of alternating EMF? The phase angle was omega t. And what we got? Phase angle of alternating current when only resistance R is connected, that also omega t. Means what? We got the conclusion, whenever the pure resistance R is connected with AC source, okay, only the resistance R is connected with AC source. In that condition, the phase angle of voltage and phase angle of current will remain equal. Okay, you can take a screenshot of this. Okay, now students, I am going to remove this portion for making graph. Look students, both having same phase angle. Here I will take I or EMF, okay, combinedly, and here we'll take phase angle omega t. This graph is representing the current EMF. Okay, suppose that is a peak EMF, and same graph with same point, that dotted graph will representing the peak current. Okay, and both having the phase angle omega t. Both, okay, this is the point where both the graph will start. Okay, and both having the phase angle omega t. And that we got practically also, that what was the phase angle? E equals to E naught sin omega t is the alternating voltage, and I equals to I naught sin omega t is the alternating current. For which case, when the only resistance R is connected, EMF having the phase angle, voltage having the phase angle omega t, as well as current also having the phase angle omega t. So that's why origin point is same for EMF and current, and this is said to be peak EMF and peak current. Dark graph is showing the EMF and dotted graph is showing the current. Okay, and both having the phase angle, same phase angle omega t. That is a graphical representation. One more graph will make, that is actually said to be phasor diagram. What is phasor diagram when only R is connected with AC source? Actually, the graphical representation of current and voltage, okay, along X and Y axis by a rotation diagram, okay, that's showing the phase angle of current and voltage. Such diagram is said to be phasor diagram. What students? The graphical representation of current and voltage along X and Y axis by a rotation diagram, that shows the phase angle. So that is X and that is Y axis, okay, and that is origin. Look at students, this is the EMF, Okay, that is alternating EMF. This graph is showing about EMF, and same graph will pass. Okay, actually these are not separate lines, these are on one another. Dotted line that is showing current, and both having the same phase angle omega t. So this is a 360 rotation diagram that generally shows the phase difference, okay, between current and voltage along x and y axis in coordinate geometry. Such diagram is said to be phasor diagram. So EMF and current having same phase diagram in case of when resistance R is connected with AC source. Okay, students.